Okay, what we're going to look at are three different items today. The first one we're going to look at is causation. It is a strong relationship. We know that there's a strong relationship between cigarette smoking and death rate from lung cancer. So the question is, does smoking cause lung cancer? And the answer is yes, it does cause lung cancer. Okay. Now, if you look at this little diagram right here, we can see that X causes Y. X happens to be your smoking. All right. So this is your smoking right here. Let me go ahead and put that in. So that's smoking. Your lung cancer is in response to the smoking. So this is a classic example of causation because X directly causes Y. If you notice, there is a solid line here, all right, and that solid line indicates uh, the solid line right here indicates that that is a direct cause. The dashed line indicates that there's a strong association. Okay. All right. Next page. When we talk about we know that there's a strong association between the availability of handguns in a nation and that nation's homicide rate for guns. So the question at hand, does easy access to handguns cause more murders? All right, remember, you've got to look at that key word. That key word right there is causes. Does the access to easy handguns cause more murders? You can't really say that that is the cause or that does cause. It might be a byproduct of it, but it's not directly. Uh, it doesn't directly cause it. All right. So that is different than the first one. It's a lot different than this first one of does smoking cause lung cancer? All right. Let's look at a different scenario. Okay. Does owning a television extend life? Well, we talked about this today. That your response variable is going to be life expectancy, and your explanatory is going to be the number of TVs per person. So here's the statement. There is a high positive correlation that nations with many TV sets had higher life expectancies. My question to you was, could we lengthen the lives of people in Botswana by shipping them TVs? And the answer is no, we can't. There might, because people own TVs, could be an indication that their country is very wealthy. Okay, so because they're very wealthy, they're able to afford luxuries like televisions or iPads or something like that, which means they could also afford proper living quarters, better food, um, better insurance, better medicines. Okay, so this is an example of, let me pull this off to the side, nonsense correlation. Oh, hold on, there you go. Nonsense correlation. It makes no sense that you would try to correlate these two things, that you try to find a relationship between the two. All right. Now, let's go to this next section. Now, this is an idea or an example of a lurking variable. A lurking variable, such as wealth over here, uh, has an important effect on the relationship. So the relationship between TVs and life expectancies, it has an important important effect on these two variables, but is not one of the explanatory variables. Okay, even though wealth causes the nation to have an increase of TVs, wealth also causes or can be a direct cause of life expectancy. Because wealth has a direct effect on both of these variables, it creates what seems like a strong positive correlation between, or strong correlation between life expectancy and TV ownership, or the amount of TVs owned by people in the nation and what their life expectancy would be. So national wealth influenced both sale of TVs and life expectancy, thus creating a high correlation even though there is no direct connection between the TVs and life expectancy. All right, let's look at the next slide. What causes obesity? Okay, we talked about the result of a study of Mexican American girls aged 9 to 12. Okay, this is a typical study. They measure the body mass index, BMI, which is a measure of weight relative to height for both the girls and their mothers. High BMI indicates either overweight or being obese. All right, some of the things that they looked at were the hours of television watched, the minutes of physical activity, the intake of food, And the result that they came up with was the BMI of these girls were weakly correlated with the physical activity, diet, and TV. In fact, their correlation was a negative 0.18. That is really low. We would expect that there would be a high, at least somewhat moderate correlation, if any, between the body mass index of their physical activity, diet, and TV. Right? Mainly because if a person has a good diet, they're not going to be as heavy, or if a person watches less TV, then that means they're going to be more active and therefore would not have a high BMI. The strongest correlation actually came from the BMI of mothers, which indicates genetics. So their correlation was 0.506. So down here in this statement, therefore the BMI of mothers can only explain, we're looking for R squared. We want to know how much can be explained by this explanatory variable. Well, you take 0.506 and you square it. So 0.506 times 0.506 gives you 0.256. So that's what we're going to put right here, is 0.256. There you go, 0.256. Now, hold on a second. Let's see if I can use a pen. Oh, let me undo that. All right, here we go. So let me get a pen here. All right, we're having a little technical difficulties here. All right, so let's go ahead and use a pen here. So what we want to see here is 0.256. All right. Now, let's change that to a percentage, and that's going to be 25.6% of the variation among the daughters' BMI. Okay, so therefore the mothers can only explain, the BMI of the mothers can only explain about 25% of the variation among the daughters' BMI. Not a very good amount, okay? So now what we're going to do is we're going to look at the next page. If only 25, so can we use R or R squared to say how much genetics contributes to the daughter's BMI? The answer is no. The reason is it is confounding. All right, it is confounding. Let's look at this diagram here. I'm going to move this out of the way real quick. All right, so if we look at this diagram, we notice that this is an example of confounding. All right, where we say that the mother's BMI has a direct effect on the daughter's BMI. Okay, well that might be true for, but it only explains 25% of the mother's BMI's change in, or the explains 25% of the change of the daughter's BMI from the mother's BMI. Now, other things that happen to be in play are the eating habits, the depression, the physical activity, and the TV, watching TV. So all those things are attribute to the daughter's BMI. Now, notice that there's a strong relationship between these items and the mother's BMI. There's also a strong relationship between the mother's BMI and the daughter's BMI. But this means there's a direct effect. Eating habits, depression, physical activity directly affect the daughter's BMI. The mother's BMI genetics directly affects the daughter's BMI. So this isn't where what we call confounding. We don't know which one of these causes what percentage, and in fact, they could either they both cause this, cause the mother's or the daughter's BMI to be high. So you don't really know which one causes more. That's why it's confounding. Sounds confusing. Is how I like to relate it. On the next page, we talked about high SAT scores. High SAT scores does not mean you're going to have a high college GPA. Rather than study habits affects both high SAT and high college GPAs. Lack of sleep, also intelligence. So this is another example. So you have three things. You have direct causation. You have common response and confounding. This happens to be an example of common response. Let me see if I can spell this right. So common. So common response. Okay. Let's go to the next page. All right, so the next thing we talked about is what happens when best evidence for causation comes from a well-designed experiments. Well, we talked about putting people in harm's way, such as having them live near power plants or near power lines, knowing that there are studies that indicate that power lines could cause leukemia. Well, let's say we want to test that. Well, it's not really ethical in order to put people in harm's way. So whenever you can't have a well-designed experiment, these are the 5 things that you need to make sure are in place whenever you are searching for causation. First of all, the association has to be strong. For example, association between smoking and lung cancer is strong. Okay, that's one example of it. Second, the association is consistent. Again, there were many studies of different kinds of people in many countries linking smoking to lung cancer. That reduced the chance that a lurking variable specific to one group or one study explains the association. All right. Again, higher doses are associated with stronger responses. People who smoke more often or more cigarettes per day or who smoke over a longer period of time get lung cancer. Then people who stop smoking reduce the risk. Next, the alleged cause precedes the effect in time. Lung cancer develops after years of smoking. Lung cancer kills more men than any other form of cancer. Lung cancer in women rose along with smoking and now has passed breast cancer as the leading cause of cancer death among women. And so finally, the alleged cause is plausible. Experiments with animals show that tars from cigarette smoking do cause cancer. So try to make sure that these 5 things are in place whenever you're trying to give evidence of causation. And I do believe that is the end.